is equals to k. You can therefore say, now for us to get this constant, the value of this k, and we have been told that when when p is equals to 3, p equals to 3, q is equals to 2. Q is equals to 2. So we want to know the value of this k. Now, our k, from the knowledge of the subject or formula we treated in the last subtopic, we can make k the subject of the formula, which will be equals to p divided by q squared. That is, we divide both sides by q squared. So, which is equals to our value of p is what? Is 3. And our value of q is 2. Then that will be 2 squared, which is equals to 3 all over 4. So we can now put the value of k back into the equation. We can now say that our p is equals to what? 3 all over 4 q squared. It now said, okay, the question now went further that we should calculate q. We should find q when p is equals to 6. We should find q when p is equals to 6. Now we are still going to make use of the knowledge of change of subject or formula. Here, that will be our q from this equation. Let's name it 1. From this equation 1, we can easily say that our q squared is equals to what? P all over k. Therefore, our q is equals to the square root of p all over k. Now, we have been given our p as 6. P is equal to 6 all over, what's our k? That's 3 over 6. That is 6 over 1 divided by 3 over 4, the square root of everything, which is equals to the square root of 6 all over 1 times 4 all over 3. Here we have 2. Okay? Is that? Yes. That will now give us 8, square root of 8, which is equal to square root of 2 times 4. Which will now give us, the square root of 4 is 2. That will be 2 root 2. So our q is equal to 2 root 2. Example number 2. If v is directly proportional to the square root of d, and v is equal to 16 when d is equal to 64, find v in terms of d. Now, what this expression, that is v is directly proportional to the square root of d, what it implies is that v is equal to k square root of multiplied by square root of d. And then for us to get this k, because the question is asking of us is that we should find v in terms of d. That means we have to get out this value of k and then slot it back inside this equation. So what we'll be having here, to make k the subject of the formula, we'll be having k is equal to v all over square root of d, which is equal to, what's our v? Our v is 16, and our d is 64, which is equal to square root of 64 is 8, 16 all over 8, which is equal to what? 2. So we can now bring this back into the equation to get our v in terms of d. That will now be v is equal to 2 root d. And now we'll be taking another type of variation, which is inverse variation, just as we are having here. If two variables x and y are such that when x increases, y decreases, or when x decreases, y increases, then the two variables are said to be inversely related. Such relationship can be written as x is inversely proportional to 1 over y, or y is inversely proportional to 1 over x. Let's take an example. If x is inversely proportional to n, just like we have here, and x is equal to 72, that is, x is inversely proportional to n, x is inversely proportional to n when x is equal to 72, and n is equal to 8, and n is equal to 8. Now for us, remember the other time we said if you have to replace this proportionality sign, replace it with is equal to sign and then k. So we will now be having something like this: x is equal to k multiplied all over n. Now for us to get this k, which will be, we'll just cross multiply, we'll now be having is equal to nx. So we can easily from here, we can now get the value of our k, which is our n is 8, and then our x is 72. Our k is equal to 8 times 72, which is equal to 576. So we can therefore say that our x is equal to 576 all over n. Now the question now went further, and then said we should find x when n is equal to 20. Find x when n is equal to 20. So we are going to slot in our value for n back into this equation. This is our main equation. Now we'll now be having x is equal to 576 all over 20, which is equal to 28.8. Now the B aspect said we should find n when x is equal to 6. Find n when x is equal to 6. Now we are going to make n the subject of a formula. So our n is equal to 576 all over 6, which is our x, which is equal to 96. The next type of variation is the joint variation. Joint variation is the combination of direct and inverse variation. For example, the period of a pendulum t is equal to 2 pi times the square root of L over G, where t is a function of the length and then the gravitational force G of the pendulum, and 2 pi is known as constant. T is said to vary directly as the square root of L, and inversely as the square root of G. Thus, t is said to vary jointly as the square root of L and G, and 1 over G. So we can easily say that t is proportional to, directly proportional to L and inversely proportional to the square root of G, which implies that t is equal to k square root of L over G, where k is known as the constant, which is equal to 2 pi. We'll now take an example. Our example says x, y, and z are related quantities such that x varies directly as y and inversely as the square root of z. When x, the question said x varies directly as y x varies directly as y, and inversely as square root of z, and inversely as square root of z. When x is equals to 300, x is equals to 300, and what? Y is equals to 65. Y is equals to 65. So from this expression, we can easily say that x is equals to ky all over square root of z. Now, to find the value of k, that will be k is equals to x root z all over y, which is equals to what? Our x is 300, our y, our z is 25. Okay, our z is also 25.